CPU will going to process. Input and output is taking place. Along with that, if I am taking an input, then the CPU must be able to process at that same time. The action of T1 and T2 are interleaved. That means we are mixing it. The result of this schedule is equivalent to the running of T1 as well as running of T2. So when we are interleaving a short transaction with a long transaction, at that time there will be a chances of execution of this short transaction in a quick manner than the long transaction. Hello everyone, welcome back to the session 2 of Unit 4, and we are in the B.C.A's 4th semester. Subject called Database Management System. In short, it is Dbms. I am Rohini DS, Department of Computer Science, Vidhyaashram, First Grade College, the Temple of Excellence, MYSURU. So before getting into our today's session, we'll just have a quick recap of my previous session. As we all know that in the first session of this unit, we have discussed regarding this transaction processing. So we got to know that, and we also learned regarding the transaction processing system. It will going to take care about the transaction, whatever is happening in the database, and also have discussed regarding the ACID properties. So A defines atomicity and C specifies consistency and I represent isolation, D in the sense durability. So if I wanted to consider any of the transaction as an efficient transaction, then it has to follow this ACID properties. And also we have a transaction state. It can be of any one of the state out of active, partially committed, committed, aborted as well as failed. So out of that stages, any one of the state will be there in the transaction at the time of initiation of a transaction to the termination of a transaction. And also I have discussed regarding what do you mean by transaction as well as scheduling. So that is what schedules that represent the series of actions or activities which is happening in a database. That activities or actions can be either read, write, and all of the committing and fail of the transaction what is happening in a database. And also I have discussed regarding the types of schedules. So in this we have a serial and non-serial schedules. This is what I have discussed in my previous session. So in our today's session we are going to see how this non-serializability or serializability will going to help in order to have this concurrent execution of a transaction. We'll see what it means, and also we'll discuss about the serializability. Already we know we have a serial schedule and non-serial schedule. So in order to link or in order to get to know regarding the serializability, in prior we require the types of schedules. So that is also I will be discussing in our today's session, and also we are going to see about the types of the serializability. It will include result equivalent, and also we have a conflict equivalent, and also we have a view equivalent schedule. So all these are the types which comes under this serializability. We'll discuss one by one in our today's session. Let me get into this one, that is regarding concurrent execution of transaction. What do you mean by concurrency here? First you need to understand what is transaction. That is what set of action that is taking place, that can be read or write operation, right? So when it is happening serially, then that comes under serial scheduling. If there is interleaving in between the actions, or if there is no gap in between the actions, if it is taking place concurrently, then that is what non-serializability. So when there is a non-serializability, when read and write operation both are taking place together, and CPU is not idle, it is busy, and both input and output operation is taking place together, and CPU is also working together parallelly. So if a number of users are accessing the same content at the same time, then we are going to call that as a concurrent usage. So here, what do you mean by concurrent execution of a transaction? When that concurrent usage is happening on the transaction at the same time by the n number of users, if they all are trying to access the same content, then we can say that as a concurrent execution of a transaction. So that the Dbms interleaves in the sense what? It will going to mix, or it will going to combine both the activities. So that is what actions of the different transaction. That different transaction can be T1, T2, T3, any number of transaction we can have. So actions in the sense it can be read or write operation, right? So here the DBMS interleaves or mix or combines the actions that can be read or write operations of different transaction. It can be T1, T2, anything it can be, to improve the performance. So if it is serial in nature, then we have to wait, right? If I have 100 of transaction in T1 and only 20 transaction in T2, T2 has to wait until all the 100 transaction of T1 gets to satisfy or to execute. That is what it will, in order to improve the performance of this transaction, we are going to have this, or this DBMS will going to mix the action of read and write from the different types of transaction. And in terms of increased throughput, in order to increase the number of actions taking place at a particular time, that is what throughput here, or to improve the response time. So when the response time is less, at that time the efficiency will be high. If the response time is more, if it is taking much time in order to give a resultant, then it will be not so efficient in terms of transactions. So here, in order to improve the throughput and also in order to improve the result or response time for this short transaction, but not all the interleaving should be allowed. So here simply we should not allow all the transaction in between to get execute. We have to allow only the transaction which is necessary and which is urged in nature. That is what in when it comes to the concurrent execution that you need to remember. So here, ensuring transaction isolation while permitting such concurrent execution is difficult, but it is necessary for the performance reason. So when we are interleaving or when we are mixing a number of actions of a different transactions together, at the time it must ensure that there must be isolation. So if I am combining T1, T2 action, if I am doing any changes in the T1, that should not affect the content of T2. If you are doing any changes in a T2, that should not affect the content of T1. That is what isolation needs to be improved when we are interleaving a transaction. So when we are having this concurrent execution, then it has to follow the consistency in a database, and also it needs to follow this isolation mechanism. But in order to improve the performance, it is necessary to have this concurrent execution. But if we have a concurrent execution, then there might be a threat to this isolation and consistency of a data in a database. But being a user or being an administrator, they have to take care about all these things. So while one transaction is waiting for a page to be read in from disk, the CPU can process another transaction. So the main what agenda of this concurrent execution is what? CPU should not get idle. It should not sit simply without doing anything. So if I am taking what input or output, or if you are reading or writing a content to the disk, then CPU should process any other transaction. So at that time, the resource will going to be utilized in a proper manner. So here, IO activity, that means input and output activity, can be done in parallel. So it need not to be serial. So I will read first, I will write next. That should not be the case. So here, both input and output has to take place parallelly with CPU activity in a computer. So CPU will going to process. Input and output is taking place. Along with that, if I am taking an input, then the CPU must be able to process at the same time. That means it has to take place parallelly. Overlapping of this input, output and CPU activity reduces the amount of time disk and processors are idle. So here, when we are combining this input output activity along with the CPU activity, that is processing of that input output is taking place parallelly, or at a time it is taking place, that will going to improve the performance. Along with that, it will going to reduce the time disk. So if it is taking for input and output, and time another it's taking for the resource to be processed. So that is all what time consuming. In order to reduce all those things, it is necessary to have it parallelly, and it will going to increases the system throughput. What do you mean by throughput here? The average number of transactions completed in a given time. So what is the number of transactions that has been completed in a 30 minutes? If it is 100, then in the 20 minutes, if it is 200, then this will be more efficient. That means when the throughput is increasing, the number of transactions which is executing for a particular time is more, then the throughput will be high. If the throughput is increased, then that also going to reduces the response time and improves the performance of a system. So that by keeping all those in mind, we are not supposed to leave the CPU activity idle. So when it is taking place parallelly, then it will be easy. Fine. So next, interleaved execution of a transaction or a short transaction with a long transaction usually allows the short transaction to complete quickly. You just imagine I have a two transaction called T1 and T2, and T1 will going to take 10 minutes of time or 10 minutes CPU time, and it will take only 2 minutes. So here, when I am mixing or combining T1 and T2, that means when we are having this interleaved execution, at the time, instead of T1 get executed fastly, this T2 will going to be executed. That is what. So when we are interleaving a short transaction with a long transaction, at that time, there will be a chances of execution of this short transaction in a quick manner than the long transaction. So in the serial execution, a short transaction could get stuck behind long transaction. So this is what non-serial. So we are interleaving a transaction here. Both T1 and T2 is combining together. They are working it parallelly. What if it is serial in nature? At the time, if the T2 is what small transaction, T1 is long transaction, this T2 will going to stuck behind this long transaction. It may take more time. So once the T1 is completed, then only this T2 can be executed. So that may lead to the unpredictable delays in the response time. If it is taking much time, or if it is of only 2 minutes, it has to wait until the T1 is going to get processed. So that will going to reduce, or that will going to take the more time for response, or average time taken to complete a transaction will going to be increased. That is also one of the reason why we should not have a serial execution. So if we have a serial execution, then there will be a consistency in the data. There will be a consistency in the data, and also it will going to maintain isolation. If we have a non-serial scheduling, at the time it will going to interleave the actions or read and write operation in a database, but there is no much consistency over the data. That is also needs to be considered here. And also now we'll see about this serializability. So till now we got to know what is transaction, right? And then we got to know what is serial transaction or a serial scheduling. So first of all, we got to know regarding the scheduling, right, or schedules. In that we have a serial schedule, and also we have another type called non-serial. That means which is it will going to interleave the action. So here no interleaves or no interrelation of an action. That means transaction will going to takes place one after another in a serial manner. When it comes to the non-serial, at the time it will going to take, or T1 and T2 both are taking place parallelly. So CPU idle time will be less in the non-serial scheduling, right? So whether this, when we are having this serial and non-serial, there will be both advantage as well as disadvantage. If it is serial, there will be more consistency, and the what response time will be somehow more than this non-serial. So concurrent execution will not going to be entertained in this serial. Why? Because concurrent in the sense I need to access T1 and T2 at a time. So but that is not possible in the serial. Why? Because it is one after another. So that is what the disadvantage. If I come to this non-serial, there is no much consistency in the data, because there is a mix and match of a transaction happening in the non-serial schedule. So there will be no much consistency in the data, but it will going to improve the concurrent execution of a data in a database. And also we have to be very cautious regarding the isolation process in the non-serial scheduling. So if I wanted to check, or if I wanted to get to know whether the resultant of this non-serial scheduling is serial or non-serial in nature, then in order to get to know the result, whether it is same or not, so if I am doing it serially or if I am doing it non-serially, the resultant should be same. So whether are we getting a same resultant or not, if we are examining that, then we require this serializability. So mainly the serializability will going to examine whether the non-serial schedules are executing the resultant as per the requirement, yes or not. That is what we are checking with the help of this serializability. You can see here, a serializable schedule over a set S of committed transaction is a schedule whose effect on any consistent database instance is guaranteed to be identical to that some complete serial schedule over S. So here just understand, I have two transactions T1 and T2 that will going to be executed serially. No problem, nothing here. T1 will going to execute first, T2 will going to execute later. So we got some resultant. So in this non-serial, I have T1 and T2. So both needs to be takes place parallelly or concurrent execution is happening in the non-serial scheduling, right? So after getting the resultant of this T1 and T2 is producing the same result as of this serial, yes or no, that we are checking with the help of this serializability. That is what this definition defines. The database instance that result from the executing the given schedule is identical to the database instance that results from executing the transaction in some serial order. So whether we are doing it concurrently or a serial scheduling or a serial order, then it needs to be identical in nature. So both needs to be same. So if the resultant of T1 and T2 is A, and the resultant of T1 and T2 in the non-serial also should be A. So if you are finding both are identical or not, then we have to use this serializability. Fine. This is regarding serializability. And possibly concurrent schedule is serializable if it is equivalent to a serial schedule. That means non-serial schedule. If it is concurrent, what it means? That is non-serial schedule. If the non-serial schedule is a serializable, if it is doing it parallelly, T1 and T2 is transaction taking place parallelly, if the resultant of that is equivalent to the value of the serial scheduling, then we can say that both are identical. So even though the action of T1 and T2 are interleaved, that means we are mixing it, the result of this schedule is equivalent to the running of T1 as well as running of T2. Both needs to be identical. Whether I am doing it separately, whether I am doing it parallelly, it needs to be same. That is what we meant serializability. So T1's read and write of B is not influenced by T2's action on A. Whether whatever we are doing a changes in T1 and T2, and that does not affect on each other, but at the time of execution or at the time of resultant, both needs to be identical. That's what. And the net effect is the same if these actions are swapped to contain the serial schedule T1 is to T2. So whether we are doing write or read operation on object A, B, whatever it can be. But once we got the net effect, that means once we got the resultant, both needs to be same. T1 should be parallel to T2 and T2 should be parallel to T1 action. So here you can see that we have a two transaction named T1 as well as T2, and we have a read operation, read of object A, write of object A, and here read of object A, write of object A. So we are doing it serially here, right? And if I am checking it at the last, a serializable schedule is equivalent to T1 is to T2, whether it is interleaved or it is not interleaved, whether it is parallelly doing or serially doing, whatever the resultant we have from T1 and T2 should be identical in nature. Both should be same. Then only we can say that is what serializable schedule. So here this schedule is not a serial schedule, but it is equivalent to the schedule of T1 and T2. So here you can see that. So this one is related to serial execution. So after one transaction done over, then another transaction will going to takes place. Read of A and write of A gone over, then write of B got over, then it will going to commit. Again come to the transaction to read of object A and write of object A over, read of object B, write of object B over, commit. So then it is taking place serially, one after another. But in this non-serializable schedule, at the time it is not serial in nature. So it is going to interlude. So you can see here, read of A, and we are doing some operation, write of A. And also here I have a read of A, temporary A into 0.1. So all these operations are taking place parallelly. I am reading a content, I am writing a content, I am writing and reading. Both are taking place parallelly. But after the resultant, whatever we have in a T1 should be matched with this T2. So if both are what? Equivalent to each other, then we can say that this is what? Maintaining a serializability. This is what the example. So then what are the types of serializability we have? So we have three kinds. In that, first one is related to result equivalent schedule. So what do you mean by result equivalent schedule? You just imagine we have two schedules. One is S1 and another one is S2, right? Are said to be result equivalent if they produce the same output obtained when the schedules are serially executed. I have some set of operations in S1. You just imagine I have T1 and T2. Take one more schedule called S2, and I have some more operation called T1 and T2. Fine. So then when I can say result of S1 and S2 both are needs to be equivalent in nature. So if both are producing a same output from the S1 and S2 when we are executing it serially. That means what? T1, T2 will going to be executed from S1. Next I will come to schedule 2, T1 and T2 of this S2 will going to be executed. If both are producing a same resultant or a same output, then I can say that it is result equivalent scheduling. What about the next type then? That is conflict equivalent schedule. What it mean? When either of a conflict operation, so that operation can be read-write operation or a write-read operation or a write-write operation is implemented on the same data item at the same time. So whether read-write, write-read as well as write-write. So this operation can be anything. When we are performing all the conflicted operation on a same data at the same time within a different transaction. So you need to imagine we have a T1 and T2 here. So I am going to perform read-write, I am going to perform write-read and also write-write here, and here same read-write, and also I am performing write-read, and we have a write-write. So here I am performing same set of actions, or I am performing same set of operations here in different transaction, that is in T1 and T2. Then the schedule holding such transaction is called to be a conflict schedule. So if both the transactions are different here, right? T1 and T2 I have, but I am performing the same set of operation which comes under a same schedule or which comes under a single schedule. Then if you are having all these of operation, if it is performing at the same time to the same set of data at a same moment with a different transaction, then we can say that as a conflict equivalent scheduling. This is also second type. We'll see the next type of scheduling here. View equivalent schedule. So what it means? Two schedules. So that two schedules, let me consider S1 and S2. One can be what? Serial schedule, and another being non-serial. So S1 transaction whatever we have can be serial, and S2 transaction which comes under S2 or a serial schedule 2, that can be non-serial schedule, or said to be view serializable. When I can say that as view equivalent scheduling or serializable if they satisfies the rules for being view equivalent to one another. So in order to look alike from both schedule 1 and schedule 2, then we can say that what? View equivalent serializability. So let me consider S1. So in this S1 I have a two transaction. Let me consider T1 and T2. This will be of two transaction which comes under S1, and I have S2. So in that it will going to be non-serial then T1 and T2 transaction will be there. If it is serial, how it needs to be? Read of A and then write of A. So here it needs to be read of A and then write of A. So but if it is non-serial in nature, at the time read of A, write of A. It will be read of A and then write of A. So if it is serial in nature, this will going to execute first, next it will comes to the second transaction. If it is non-serial, both are taking place parallelly. But if you consider this one and this one, both are looking alike, both are identical for the view purpose, then we can say that kind of serializability as a view equivalent serializability. If it is taking place differently, whether serially or non-serial scheduling is happening, but for the view to the user it is happening in a same manner, then we can say that as view equivalent scheduling or a serializability. I hope you all understood our today's session. In my coming session, we're going to see about this concurrency control, and also in order to maintain that we have some locks concept. It's all about today's session. Let me meet you in the next session. Until that, keep learning, keep on growing. Thank you.